Hey mathematicians, let's do your unit rate homework so that we can enjoy our weekend. All right, let's get started. The first few problems are finding a basic unit rate. I'm going to choose the hardest one so that I can help you out with these. The hardest one is the first one. Okay, so we have two units, miles and hours, and two numbers that form a ratio. A rate is a ratio that is a ratio of measurable things. So miles we can measure, hours we can measure. So that's a rate. We want a unit rate, which is for every one of your second unit. So I want to know, okay, great, you can run 15 miles in 3 3/4, 75 hundredths of an hour. How far can you run in 1 hour? So that's what we're figuring out, and that is a division problem. So the first unit goes inside, 15, and the second one goes outside, 3 3/4. Now, I'm saying it like it's a fraction, and if you wanted to change it to be 3 wholes and then a fraction 3/4, you could change that to an improper fraction and divide like that. Or we can say, okay, well, we can't have a decimal out here, but if I move my decimal 1, 2 places, let me zoom in so this is bigger and we can all see, then I can have 375, which is a big number, but it's a whole number. However, I cannot do that to one part of my problem without doing the same thing to the second part of my problem. So the decimal is kind of hiding in 15. We don't see it. It's at the end. We're going to move that 2 spaces as well and fill those in with zeros. So let me rewrite what we have here. This is no longer our problem. Now we are dealing with 1,500 divided by 375, no decimal. Now, common misconception is, oh yeah, just erase the decimal. No. You have to change both numbers in your ratio by the same amount. Okay, so then you would probably not know your 375's times tables, so I would go off to the side and be like, okay, 375 plus 375, what does that equal? Add them up. Okay, that equals 700. 5 and 5 is 10. There's, 750, sorry. It equals 750. And then you can say, okay, so 375 plus 375 is 750. 750 plus 375 is 1,000. 1,125. And so you can see it's a bit of work. But the fourth one makes 1,500. So this is a unit rate of 4. That's the number, that's our answer. Miles, because that's the first unit. Per, we put a slash. Hour is the second unit. That's our final answer. Fortunately for you, if you're showing me this work, then you get credit for this one, and the next two are a little bit easier. No decimals involved. Okay, keep scrolling down then. Oops, no, I'm not trying to click on that. Keep scrolling down. Now we have a few word problems. Read the directions carefully because you do not need to spend the rest of your life doing long division. If there's a number that doesn't end, you can stop and round. You stop at the thousandths place and round to the nearest hundreds. You will not get credit if you don't show your work, so make sure you're showing it. I'm going to do number 3. About how far can Bryce travel in 4 hours if he can bike an average of 43 kilometers per hour? That means 43 kilometers in 1 hour. If I say we're actually going 4 hours, then your answer is going to be bigger. You're going to write an equivalent ratio. How do I get from 1 to 4? Well, times 4. 1 times 4 equals 4. 43 times 4 will equal your final answer. And your units there will just be kilometers because we're using this unit rate. It's not our answer. So our answer is not going to be a unit rate with 2 units, just the 1 kilometers. This one is very similar to my Oreo example in class today. You're comparing 2 things, and you can either find their unit rates, or you can just compare at any equivalent poundage, any equivalent number of pounds. So if you wanted to change 20 and 30, I don't know, if you wanted to cut this one in half and this one in half, then you'd have 10 pounds. And this one in 3 parts and this one in 3 parts, then you'd have 10 pounds. Or if you wanted to add 30 and 30 and this and this, like you can compare at any equivalent number of pounds. It's just that a unit rate is doing 2 division problems and then comparing at an equivalent of 1 pound each. All right, this is a double number line, which I don't love, so I'll do it for you so that you know what it looks like. It's basically a ratio table. NYSA uses 7 balls of yarn to knit 3 sweaters. Balls of yarn, sweaters. Balls of yarn, sweaters. Complete a double number line to determine equivalent ratios. So double number line, just like a ratio table, finding equivalent. We're not going to change the amount of yarn each sweater takes. And we are trying to figure out, how much yarn it takes for 12 sweaters. So I'm going to start with the 3 because 3 is easy and nice to count. 3 sweaters. 1, 2, 3. I'm going to put a 3 right here. I am not going to count 7 spaces on my double number line. I'm going to put the 7 exactly on top of the 3. Then I'm going to count another 3. Okay, 3, that's 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'll just keep going. If this is the spot here for the 7 to 3 ratio, then this is going to be 14 to 6. You can see how it's just like a ratio table. It just looks a little different. So you can figure out what's equivalent to 9 sweaters, how many balls of yarn, and then this number here is your answer once you find it. And if you notice, you're rewriting them into a ratio table. The ratio table, exact same numbers, pretty much the same layout. This is why I don't spend too much time on double number lines, because they're basically just ratio tables, and if you have to build something to help you, why not build a ratio table? Last bit is review. This is a ratio right here. You can find this with a proportion. This one is fractions and decimals. You should probably change both these two mixed numbers into decimals and then compare place values. This one is also a ratio, 5 red to 9 blue, and then you have 20. Well, how do you get from 5 to 20? Use that same scale factor for 9. These review are not super far, like a long time ago review. These are pretty recently that we did these types of ratios. Last one, this one I will do with you, or at least I'll set it up for you. The table shows the number of choir students. This is the table, not like a table you eat on. The choir teacher plans to arrange the students in equal rows. Okay, so that means same number of kids in each row. Each row also has to have the same number of boys and girls. So you can't have like 4 boys in one line, in one row, and then 2 boys in the next row, because that's not the same. You gotta have the same exact pattern. What is the greatest number of student rows the teacher can make? Hint, think about our Do First this morning, where we made factor rainbows. The greatest number is like the greatest common factor. So I'll do one factor rainbow. You can do the other. 48. What times what makes 48? Well, 1 times 48. 48 is even, so I know 2 times something. If you don't know exactly what that something is, you can do division. But since it ends in an 8, there will be something, and that something is 24. Let's see, 3 times, I don't know that one off the top of my head. I'm pretty sure it works. I'm just going to double check, and you can do this scratch work like off to the side. Oh yeah, that looks right. Okay. So if you don't know them, it's totally fine to just do some long division or check up on a multiplication chart. 4, here's how I check the 4s. If there's a 2 there, maybe there's a 4. If there's no 2, then you can't do 4s. If you can cut this one in half, remember we've talked about double in half. 2 times 24 makes 48. So 2 doubled times the second factor cut in half will also make 48. 4 times 12. If it ends in an 8, 5 is not going to work. 5's tables end in 0 and 5. If you have a 2 and a 3, then newsflash, you can also have 6 because 2 times 3 makes 6. So 6 times 8 equals 48. And that's actually the completed factor rainbow. So you're going to do a separate factor rainbow and list all the possible ways you can multiply whole numbers to get to 64. And then you're going to pick the biggest number that they have in common. Then just go back and fill in the ones I didn't do and enjoy your weekend.